called this little x, this little z, and this little y. Angle y, how much was angle y? Okay. Okay, so then if we use the 52-degree angle, you could use the 38-degree angle. Okay, you're going to get the same answer either way. But if I use the 52-degree angle, I'm going to use the side that I know and the side I'm trying to find. So let's say I want to find x, first of all, little x. From 52 degrees, little x is opposite. This is adjacent. So we're going to say the opposite and adjacent would be our tangent function, right? TOA, T-O-A. So we're going to write tangent of 52 equals opposite over adjacent. Okay, what does that give us for x?
6.6? Oh wait, big X or little X?
Little x. Try typing it into your calculators. What'd you get? 10.8, okay. What's the number next to the 8? So 10.9, okay. So about 10.9, it's going to round up. A lot of the answers that you're going to see, especially on big ideas, you round to the nearest tenth. Okay, little y. Oh, we already know little y. Little z, I should say. This time, I'm still using the 52-degree angle. I'm still using 8.5, but this time we're going to use z, and z is the hypotenuse. So we're going to use the adjacent side because we know it. We're going to use the hypotenuse because we're trying to find it. So adjacent and hypotenuse is A and H. So we're going to use cosine, right? Cosine of 52 equals adjacent over hypotenuse. Okay, so this, and I don't think we had any others like this yesterday, but z is on bottom. We saw this last week though. When z is on bottom, what's our process here? What do we got to do in our calculators? We're gonna flip-flop these two whenever z is on bottom. Okay, so we're gonna end up taking 8.5 divided by the cosine of 52. Okay, what's that give us? Okay, 13.8. All right, so that would give us, when it said solve, we've now got every piece of that triangle. We got 3 sides, we got 3 angles. Okay, any questions on setting up the equations or calculator? Are we kind of getting the hang of setting up the equations? Which trig function to use? Okay, we don't just want to guess. We want to try to pick out which trig function we got based on the information that we got. Okay, down here, not really any problem, but there's really 2 different types of problems. I'm going to use the Pythagorean theorem when I have what? What do I have to have in order to use the Pythagorean theorem? 2 sides, okay? So Pythagorean theorem is a good method to use anytime we're given 2 sides. The very first couple of examples that we had on the notes had two sides given to us, and we used the Pythagorean theorem. On this last one we just did here, we had one angle and one side. So if I don't have two sides, I can't use the Pythagorean theorem, so I'm just going to strictly use trig, and that's it, nothing else. Okay, you're not going to use the Pythagorean theorem or anything else that we've done. Okay, none of the problems that we're doing right here are special triangles. Okay, in order to use those special triangles that we made a while back, it has to be a 30, 60, 90, or a 45, 45, 90. So those are pretty specific and can only be used in certain situations. And none of the problems that we're doing here have any of those angles to work with. Okay, but everything that we're doing in this chapter is a right triangle. So we keep seeing right triangles over and over again, just a little bit different situations with each one. Okay, this one here is kind of a story problem. And we're talking about a stage, and a lot of times stages are called, have what they call a rake to them. And it's really just a slope. Like sometimes on a roof, roofs are sloped, but the name of it is a pitch. It's just the name that we use for that. Let's put our phones away, guys. Okay. So it's just, we have different names for different things, but they're still sloped, right? So in this case, your school is building a raked stage, and the stage is visible to the audience. And the reason they rake it is because if the audience is out here in front, if you're in the very back of the musical or whatever's going on, then if you're elevated a little bit, it's easier for people that are down in the audience to see it, right? If everything was flat, some of the people in the audience wouldn't be able to see it. So sometimes, like our auditorium is sloped back, so we can see the stage a little bit better, but sometimes stages are sloped. And so it kind of depends on the setup. And so this case, you can tell the angle is not very big here. The angle of elevation of this stage is not much, and it doesn't have to be much. But as I fill in the information here, the total rise is 2 feet, so it's only going 2 feet up. The distance from the front to the back that's visible to the audience is 30 feet. We're trying to find this little angle right here. So if this is the angle that I'm trying to find, what side would 2 be from that angle? Opposite. And 30 is? Okay, so, and it's kind of hard to tell in this picture, but here's the 90, right? And so this side here is my hypotenuse because it's across from the 90. It's kind of hard to see that 90-degree angle in there. But this side here would be my hypotenuse. So we have the opposite, we have the hypotenuse, and which trig function are we going to use? Okay. So we're going to go sine of, and I'll just call this angle x. You can call it whatever you want. Opposite over hypotenuse. Okay. Here's what you got to identify. We're not looking for a side here, we're looking for an angle. Anytime we look for an angle, what do we have to do in our calculator? Got to do the -1 button. Okay, so we're going to say x equals sine -1 of 2 over 30. So the angle's not very big, okay? It's only 3.8 degrees. And the question here, we want the rate to be less than 5 degrees. 5 degrees or less. And so this one would work. We would say, yeah, that's good enough. The reason why is you don't want it to be too steep, right? You got a lot of people that are performing on the stage, and if it's too steep, then it would be harder to kind of go up and back. It's kind of like a handicap ramp. When you think about a handicap ramp, when I build, or if I was to build a handicap ramp, we're not going to build one that looks like this, right? That would be really hard for the people with the wheelchairs to go up and down. So there is a certain angle that those handicap ramps have to be made at. If they're not made at that specific level, then they would have to go back and restart the whole project over, because it wouldn't pass inspection. You got inspectors to come out and make sure everything satisfies whatever you've done. Okay, so if you're a contractor, you're doing things like this every day. You're trying to make sure that as I go from the bottom to the top and I'm building this ramp, it has to fit certain specifications, and you have to figure out what that is. Okay, there's a guy that I coach with that is an engineer, and he told me the other day that he uses trig and the Pythagorean theorem every single day in what he does, because he builds basically stairs or steps to get up to the top of different things. And so he has to make things to a certain specification. If he doesn't do it just right, then they have to go through and they have to redo the whole thing. Okay, so when you think about where could we use this, when can be used, there's a lot of different scenarios where we have to make sure that we know a little bit of math to get where we need to be. Okay. The second one, the only thing I would say about this second one, you have to kind of be careful of the wording. This time, the 20 is going to be down here. It's 20 feet from front to back, not the part that's visible. Up here it said the part that's visible is 20 feet. This time, it's just 20 feet from front to back, and it has a rise of 2 feet. Okay, so a little bit different picture. We put the 20 in a little bit different spot. This time, if I'm still looking for this angle, this is still opposite, but now this would be the adjacent side. So then that changes what trig function we're going to use, which would be tangent. And now we do the exact same thing we did in the last one, except we use tan -1 instead of sine -1.
I got the same answer with tan as I got with sine. Because if you do sine of what you get there, that was the wrong one, actually. Because they're both about 0.7. So, like, it's wrong, the numbers
Sometimes
past that are wrong, but it's like
Gotcha.
wrong formula, right
Okay.
answer.
Gotcha.
So that's why I have 5.7 written twice.
Okay. So yeah, this one would be about 5.7, and so this one would not fit the specifications because we want it to be less than 5, and 5.7 isn't quite less than 5. It's a little bit higher. Okay, I'm going to kind of go through